Welcome to Practical 3, and in this practical we'll be beginning to look at how we can work with vector attribute data. We'll be doing simple queries and more advanced queries on the attribute data, and we'll also be doing some very basic spatial queries to answer some questions. So once you've started Quantum GIS, you want to load in some data. So click on the Add Vector Data button, and then go to where the data is stored for this practical, and you'll find that in your handout. You want to select wards.shp and open it. You want to select the WGS84 coordinate reference system. And on the screen, a map of all the wards in Wales should appear. Wards are small areas for which census data is available. Once you've loaded in the wards, you want to open up the table. So right click on the wards layer in the table of contents and click on the open attribute table in the pull down menu. This shows the table for the wards layer. So each row represents a single ward, and each column are the data that we have for the wards. So we've got data on the label, which is the census label, and the name of the ward. We have the area and perimeter of each of the wards. We have something called cluster, which summarises the demographic of the ward. Then we have some basic information on the population size and the number of males and number of females. So what we're going to do is some very basic analysis of the table. The first thing you can do is sort the data. So if you click on a column label, such as name, this will automatically sort the wards into alphabetical order based on their name. If you click on area, it'll sort the data based on numerical order, so you can find out very quickly which is the smallest ward and which is the largest ward. One thing we can do is produce some very basic statistics for the numerical data we have in each of the columns. To do this, click on Vector in the menu header and select Analysis Tools from the pull-down menu. And then from the other menu that appears, select Basic Statistics. In the dialog box, make sure that you have wards as the input vector layer, and the target field is population. And if you click OK, you'll have some very basic statistics calculated for the population column in the table. So from here it says the mean number of people that live in a ward in Wales is 3,097, and the maximum number of people that live in any ward is 16,965. So it allows you to calculate very basic stats. And if you want to calculate other stats for other columns, just change the target field so you can calculate for male population and female population. The next thing we want to do is calculate some group statistics for the data in the table. To do this, we have to make sure that the group statistics function has been loaded into the Quantum GIS software. So if you click on Plugins in the menu bar, and then first of all, just click on Manage Plugins, and then type in Group Stats. We're just checking to see whether it's been installed or not. As you can see, it appears here, so it's already been installed on my computer. Just make sure that this little checkbox has been enabled, and so the Group Stats function is visible in the menu bar. If the Group Stats plugin hasn't been installed on your computer, then you need to install it. So go to the Plugins menu and click on Fetch Python Plugins. Once you've done this, it will give you a list of all the different plugins that are available. Type Group Stats, and the Group Stats plugin should appear. Select it, and then click on the Install Plugin button. Once you have done that, close down the dialog box, go to the Plugins menu, select Manage Plugins, and then just make sure it's installed by typing Group Plugins and enabling it. Click OK. The next thing we're going to do is to create statistical summaries based on data stored in more than one column in the attribute table. And we do this using the group stats function that you've just installed. So click on either the group stats button in the menu bar, or find group stats in the plugins pull down menu. Once you've opened the dialog box, make sure that the vector layer is wards. The field that we're going to classify is cluster, so choose cluster from the pull down menu. And the column that we're going to summarize cluster by is population. And then click on the calculate button at the bottom of the dialog box. This should then produce a statistical summary of population by each of the demographic clusters. So if you're to sort the cluster column by clicking on it, wards described as accessible countryside, there's 34 of them in Wales. They have an average population of 1,582 people. The accessible countryside with the smallest population has 478 people living in it, and the one with the maximum population has 2,947 people living in it. This compares to wards described as edge of town. There's 18 of those in Wales. They have an average of 3,518 people living in them. The smallest edge of town ward has 1,394 people living in them, and the largest edge of town ward has 9,277 people living in them. A very important function of working with attributes tables is the ability to select particular rows on the table based upon different criteria. So in this next part of the workshop, we're going to be looking at different ways to create simple queries to search for data. So open the attribute table, and what you want to do first is to select all the records in the table that have Welsh coalfields as a cluster description. So click on Advanced Search, and in the left hand side of the box, double click on Cluster, and the word cluster should appear in the bottom in your query search box. Click on equals, and then on the right hand side click on the all button, and this should populate the values box with all the different clusters that are held in the cluster column. And we want to select from here Welsh coalfields. So double click on Welsh coalfields, and Welsh coalfields should appear in the bottom in the SQL query box. Once you've done that, you want to save the query. Click on Save, and you want to save it in the Workshop 3 folder and give it a name like Query Welsh Coalfield. Click Save, and that's saved it. And if you click OK, you should have selected only those rows which has Welsh coalfields as the cluster description. You can just display the selected records by clicking on the Show Selected Only button at the bottom of the table. And so only the Welsh coalfield rows appear, and you should have selected 80 out of the 920 rows in the full table. You can do additional searches by clicking on the Advanced Search. Now, just say you want to add to those selected records wards which have heavy industry as a cluster description. So you want to load in your saved query. So click on load and select the Welsh Coalfield query, and your previous query should appear in the query box. Because we want to select clusters which have a description of Welsh coalfield or heavy industry, we select the Or button, and then we want to select the cluster button again, cluster description again, equals, click on the Or button and select heavy industry from the list. So our query now says cluster equals Welsh coalfields or cluster equals heavy industry. So we're going to select records if the values in the cluster column are Welsh coalfields or the heavy industry. You want to save this again, click on the save button and give it a name like query Welsh coalfields or heavy industry. That will give you an idea of what the query is. Save it and then click OK. And when you click OK, it'll carry out the query. And what you should see now is that the selected records includes Welsh coalfields and heavy industry. And you should have 113 out of 920 records selected. We can also invert the selection. In other words, just say we want to select all those wards which aren't Welsh coalfields or aren't heavy industry. We can unselect the selected records and select the unselected records by clicking on the switch or invert selection button. And this will just switch the selection round. So our clusters are all the other clusters which aren't Welsh coalfield or heavy industry. And we should have 807 out of 920 records selected. It is also possible to select a subset of records from those already selected. For instance, out of the 807 records presently selected, you may want to select those of a population of over 5,000 people. We could do this by building a new query. Now, first of all, because we want to select records from those already selected, we want to select the Search Selected Only button at the bottom. Once you've done that, click Advanced Search, and then double-click on Population, double-click on the Greater Than button, and then type in 5,000 for 5,000 people. Save the query as Query Population, and then click OK. The number of selected records in the table is now 110 out of the 920 selected. All these records have a population over 5,000 people, and because you've selected from the set previously selected, they do not include records that have a cluster description of Welsh coalfields or heavy industry. The ability to select records is important, since a lot of the commands in Quantum GIS only operate on the records that have been selected. For instance, if we were now to calculate summary statistics for the population column, it will only calculate it on the 110 selected records and not the 920 records in the entire table. You can see this by doing a descriptive stats, so it's vector analysis basic stats, and selecting population. Click OK, and what you should find is that the number of rows it's been calculated on is 110, and the mean is now 7,741 people, which is different from the previous mean. This is because we've just calculated it on using the 110 wards. If you want to select all records again, you need to click on the unselect records button and make sure that you've got show selected only switched off. All the queries we have been doing so far have been performed on the attribute table. They have been non-spatial queries. However, we can also query the data in Quantum GIS by using spatial queries, queries that involve the geographical relation of the wards and the spatial relationship to other features, whether or not they're in the same layer as the wards or in a different layer. So what we're going to do is we're going to add another layer of data to the table of contents. So click on the Add Vector Data button, browse to your location of where the data is, select banks.shp, click open, select WGS84 as the coordinate reference system, and a point layer of banks should appear in the map. The layer represents the locations of all the banks in Wales in 1995, or the location of banks that have been opened in Wales in 1989, but has since closed down. Open up the attribute table, which is a very simple table. It just gives you the name of the bank, the branch, and whether it was open or closed in 1995. Now, we might want to do some very, very basic analysis. So we might be interested in finding out the total population of all the wards that contain a closed bank. So to do this, we first need to select all the rows in the bank table which contain a closed bank. So we're just doing a very basic query. So click on Advanced Search. We want the status in 1995, status 95, to equal, click on All, Closed. So the query in the SQL box is status 95 equals closed. Just save this as query status 95 and then click OK. And so only those records where the bank is closed should be selected. You click on Show Selected Only and you should have 151 out of 885 banks in the total database that have been selected. To discover which wards the closed banks fall into, we need to do a spatial query. To do a spatial query, we need to use the spatial query function. This is under the vector pull-down menu at the bottom. If you don't have it, it may mean you need to install it using the plugins. So click on Plugin, click on Manage Plugins, type Spatial Query, and if it's in the list, make sure that it's enabled so you can use it. If it isn't in the list, then you're going to have to download it using the fetch Python plugin command like you used earlier. Once you've installed it, run it, and you get a dialog box. Now you want to select the wards that contain a bank branch that has closed. Now we've already selected all the bank branches which have closed, so we need to make sure that the select source feature from is wards, and that the reference feature is banks, and that we're using the selected features. So there should be 151 selected records which have had a bank branch closure, and we're using the spatial query contains because we're interested in selecting only those wards that contain a bank branch which is closed. Once you've done that, click Apply. And what you should get is a summary of the spatial query, and on the right you have a list of all the IDs of the wards which contain at least one closed bank. I'm going to close this down, and those wards are highlighted on the map in yellow. Open up the ward attribute table, And you should see that 91 out of a total of 920 wards have been selected. And just click on the Show Selected Only button so we can see them. These wards are those which have had at least one bank closure between 1989 and 1995. So you might want to ask the question, what is the total population of all the wards that have had at least one bank closure? Well, we've selected all those wards which have at least one bank closure, so we just have to find what the total population is using the descriptive stats function. So vector, analysis tools, basic stats. In the vector input layer, select wards. Use selected features only, because we're only interested in those wards which we've selected that contain a closed bank. And the target field is population. Click OK. And we look at sum or total, and we find out that there's 380,000 people that live in a ward which have had at least one bank closure between 1989 and 1995. So you can play around with the software, do your own queries. And here's a challenge: can you answer the following question? Of all the wards that have had at least one bank closure, which ward cluster type has the largest total population? Once you've done that, you can close the Quantum GIS and the workshop is over.